the solubility-product constant. So we talked about ionic compounds and how they dissolve in water. Ionic compounds dissolving is also an equilibrium process. So the solubility-product constant, or KSP, is similar to the equilibrium expression for KEQ. KEQ is the equilibrium constant. KSP is solubility-product constant. So it's the equilibrium expression for a chemical equation that represents the dissolving of an ionic compound. Remember, we talked about this, solids are omitted from equilibrium expressions because their concentrations don't change. They're constant. So a large KSP means the compound is very soluble, and a small KSP means the compound is not very soluble. Like I said, these have not been edited, so they're not what I'd like them to be, but oh well. Life is not what I would like it to be either. So here's an equation for barium sulfate dissolving. So the solid is always the reactant because we're talking about something dissolving. So we have this solid ionic compound, and it's dissolving and coming apart into its individual ions. So here we have barium sulfate creates one Ba2 plus ion and one sulfate ion. Well, the equilibrium constant expression the KSP has the same form as the equilibrium constant expression. So we have the concentration of the products divided by the concentration of the reactant, but the reactant is a solid. It doesn't change, so we leave it out of the equation. So we call this KSP because it's something dissolving, and it's just the products concentrations multiplied by each other. Here we don't have any coefficients, and so all the exponents are ones. KSP, the solubility product constant for different ionic compounds, has all been determined experimentally, and it's published in books. There's a huge fat book. We have some, I think, in the stockroom, called the CRC, which is a chemical rubber company. The CRC chemistry, I forget the actual title, we just call it the CRC. But it's got pages and pages and pages of information about chemicals. And so you'll find tables like this that give the solubility product constants for all different kinds of things. And so we can look at these, and for something like barium sulfate, the KSP is 1 times 10 to the minus 10. The KSP is the concentrations of the ions. So if KSP is very small, that means there are very few ions that form, which means it doesn't dissolve much at all. And look at this guy, copper 2 sulfide, 10 to the minus 36. That's really, really small. So a lot of these are very, very small. If you have a larger number, then it's more soluble. So we could look at this and say, well, calcium sulfate is more soluble than copper sulfide. So we'll do more with that on Friday.